Mount Rainier is the most dangerous volcano in America. It is one of the world's most closely monitored volcanoes, and it's also hiding something that may be growing beneath its icy peak. Hi, it's me, and this is our channel. Today we're going to talk about an area in Washington state known as the Cascades Volcanic Arc. This arc is part of the larger Pacific Ring of Fire, which contains more than 75% of all active volcanoes on Earth. The Cascades Volcanic Arc consists of 30 or so volcanoes that stretch between northern California and British Columbia. Many are covered in thick ice and glaciers, and together they contain more than 160 cubic miles of magma. And while these volcanoes have been dormant for thousands of years, scientists say it's just a matter of time before one erupts again. In fact, researchers think the next eruption could come from one volcano in particular, Mount Rainier, which happens to be the most dangerous volcano in America. So let's take a closer look at Mount Rainier and why scientists say it could be the next supervolcano to blow. We'll start with some basics. Mount Rainier is located 83 miles southeast of Seattle and towers over the landscape at 14,411 feet, making it the highest peak in Washington state and the Cascade Range. But even though Mount Rainier is a stratovolcano, meaning it's steep-sided and made up of hardened lava, ash, and other volcanic materials, most people wouldn't know it just by looking at it. That's because Mount Rainier is covered in snow and ice. In fact, it has more glaciers than any other mountain in the Cascades, with 25 major glaciers covering much of its upper slopes. And these glaciers make Mount Rainier one of the most dangerous volcanoes on Earth. That's because when Mount Rainier erupts, these glaciers will melt, releasing huge amounts of water and mud that can travel far beyond the volcano. Mud flows, also known as lahars, can move faster than 100 miles per hour and bury entire towns in a thick layer of mud. About 1,500 years ago, a lahar from Mount Rainier traveled 17 miles down the White River Valley and buried what is now Tacoma under 150 feet of mud. More recently, in 1490, another lahar traveled 15 miles down the Puyallup River and deposited new layers of mud near present-day Lakewood, Washington. In fact, scientists believe Mount Rainier has produced 15 significant lahars in the past 4,000 years. But lahars aren't the only danger posed by Mount Rainier. Like many stratovolcanoes, Mount Rainier is also an explosive volcano. It has had several major eruptions in the past, but the most recent was 1,000 years ago in 1490. During this eruption, the volcano produced about 3 cubic miles of ash and pumice that fell over a wide area of western Washington. Ash fell as far away as Portland, Oregon, and parts of British Columbia, and the eruption column reached a height of 10 miles, leaving behind a layer of ash nearly 6 feet deep around the volcano. But while the eruption was powerful, it wasn't anything compared to a super-eruption. For perspective, a typical eruption releases about 10 million cubic feet of ash. A major eruption releases 10 billion cubic feet of ash, and a super-eruption releases 1 trillion cubic feet of ash. The largest recorded eruption in history released 3,000 trillion cubic feet of ash. So there's a lot that can happen between a major eruption and a super-eruption. But according to a new study published in the journal Quaternary Science Reviews, Mount Rainier may be capable of both. The reason why is magma. Magma chambers are underground pools of molten rock, and they come in all shapes and sizes. They can be small, like the magma chamber that feeds the Hawaiian volcano Loki, which is only about a mile wide, or they can be giant, like the magma chamber beneath Yellowstone caldera, which is about 43 miles wide. Now, magma chambers don't form overnight. They're created over hundreds, if not thousands of years, as magma slowly accumulates beneath the surface. And the size of a magma chamber determines the size of an eruption. So the bigger the magma chamber, the bigger the potential eruption. And while we know Mount Rainier has a magma chamber beneath its summit, scientists have never been able to image it or determine how big it is. To do that, they need to find a way to drill beneath the ice, snow, and thick layers of ash that cover the volcano. And that's exactly what scientists did. In 2021, researchers announced the discovery of a massive magma chamber hidden beneath Mount Rainier. To locate it, they used a technique called seismic tomography. Seismic tomography works by sending waves into the earth and listening for what comes back. By measuring the speed of these waves, scientists can learn about the composition of the materials they're passing through. So by listening to waves bounce back off different depths below the volcano, researchers were able to create a detailed map of Mount Rainier's interior. What they found was surprising. Beneath the summit of Mount Rainier, there appears to be a low-velocity zone or a blob of partially molten rock about 12 miles wide. Researchers say this blob is likely a magma chamber that feeds Mount Rainier's magma plumbing system. What's more, they say this magma chamber is much bigger than expected. Scientists had predicted the magma chamber would be about 4 miles wide, based on previous studies of the region. But the new results show it could be up to 3 times larger. Now, while a magma chamber doesn't necessarily predict the size of an eruption, researchers think this discovery could help explain why Mount Rainier is such an explosive volcano. Here's why. Magma chambers are usually filled with hot, bubbly magma. The bubbles are created by gases that dissolve in magma as it cools. As the magma rises, the pressure increases, causing the gas bubbles to expand. Eventually, the pressure becomes too great and the gas bubbles burst, creating violent explosions that can send ash miles into the air. And while this process is common at volcanoes like Mount St. Helens, it's a little more complicated at Mount Rainier because of the ice. When magma makes its way up through the plumbing system, it heats the surrounding rock, causing it to melt and creating channels of water. Water and magma don't mix, so the water forms its own separate pathway, allowing steam to build up and explode out of the top. In other words, the steam from melting glaciers plays a major role in creating explosive eruptions at Mount Rainier. But here's where things get really interesting. Steam isn't the only thing that can cause an eruption. Meltwater from glaciers can also create their own explosions, kind of like a shaken bottle of soda. Meltwater mixes with ash and rock fragments that have built up in the plumbing system over the years. The mixture creates a thick paste that's forced up through the volcano. Eventually, the pressure becomes too great, and the mixture explodes out of the top in the form of a volcanic mudflow. Researchers think the large magma chamber beneath Mount Rainier may be the reason why Mount Rainier has produced so much pumice during its lifetime. Pumice is a lightweight volcanic rock that forms when gas bubbles expand in the magma and are quickly released during an eruption. In other words, the larger the magma chamber, the more room there is for gas bubbles to expand, resulting in more pumice being ejected during an eruption. And pumice is explosive. In fact, some scientists believe pumice is responsible for some of the largest eruptions in history, including the 1883 eruption of Krakatoa in Indonesia and the 1980 eruption of Mount St. Helens in Washington state. So the combination of a large magma chamber and nearby glaciers could make Mount Rainier super explosive, but it's not enough to cause a super eruption. For that, Mount Rainier would need to eject more than 1,000 cubic miles of material, and that's unlikely to happen anytime soon. According to the U.S. Geological Survey, Mount Rainier is not overdue for an eruption, and no major unrest has been observed. But researchers say the volcano could erupt within the next 500 years, and they want to keep studying it to learn more about its behavior. So the next time you're hiking or skiing in the Cascade Mountains, take a moment to appreciate the beauty of Mount Rainier, and remember that beneath its snow and ice, there may be a slumbering giant. Thanks for watching this episode of SCI Show. If you'd like to help us explain even more mind-blowing space science to the whole internet, we have a Patreon where the people who want to support our work do that so that we can keep doing it. You can find it at our support page,